Hi, this is my video number 18. Number 18. Right, we deal with chain rule. Alright, if a function of a single variable, that's it, you have made this kind of problem, f of t, say, and this is x, right? And y is a function of gt, say, right? Then we can find dy dx by differentiate those with respect to x, should be dx dt, alright, dt dx. Okay. Or you can also find dy dx, dy dt if you want, dy dt or dx dt. This is by dy d y dy dg dg dt, right? Okay. Now suppose that we have z is equal to f xy, where x is a function of t and y is also a function of t. Okay, it's a function of t. Then you can find dz dt differentiate respect to t. So look at this function. This function, the independent variable is the x, z is function of x and y, and whereas for x it depend on t and y depend on t. Okay, so we can find differentiation z with respect to t. This is del f del x dx dt plus del f del y dy dt plus del f del z and dz dt. Okay, dz dt. So look at example. So if z is given as x squared y plus 3x y to the 4, where your x is a function of t, say for example sine 2t, and y is a function of t cos t. So you want to find dz dt at t equals 0. So the solution is, so it is not difficult, of course not difficult to differentiate that with respect to t. So dz dt, you can use this del z del x dx dt plus del z del y dy dt. Okay, So that gives us del z del x. Del z del x is, we have 2xy plus 3y to the 4. Del x del dx dt is cos 2 cos 2t 2 cos okay 2 cos 2t plus del z del y, that's z del y, so we have x squared plus 12xy cubed, right? And del y del t is negative sign t. So then if you evaluate that at t equal to 0, del z dz dt at t equal to 0, that will give you, okay, so you can find this when t equal to 0, you can find what y is. Okay, when t equal to 0, x is 0. When t is 0, y is 1. So you can have this point is 0, this one is 1, because 0 you got 2, this is 0, that one is 0, that one is 0. So you got 6, right? Yeah, 3 times 2, 6. Let's see. Okay. Let's consider one more example. Given that PV is 8.31T, yeah, where P is a pressure, V is volume, and T is the temperature. So the question is find the rates, the pressure is changing when temperature is 300 Kelvin and increasing at a rate of 0.1 Kelvin per second, and volume is 100 liter and increasing at a rate of 0.2 liter per second. So we want to find rate of pressure. Okay, of course, from the given function here, since we want to find P, so we can write P in terms of the rest of it, 31 T over V. Okay, then you can find dP dt. So then we want is find the rates, so P with respect to T. This is del P del T dt, this is capital dt, okay, plus del P del V dV dt, and then you just substitute the rest of it, just substitute the value. So this one is we have 8.31 over V dt minus 8.31 T over V squared dV dt. And then you just substitute the rest of it, just substitute the given value. You have 8331 over 100. That one is given 0.1 minus 8.31. T is 300 over V is 100 squared, and dV is 0.2. So solve this, you got minus 0.0415. Okay. Now let's consider, if you look at this this case here, we consider the x, variable x, is a function of a single variable t. You can see here. So z is also basically a function of a single variable t. What about, we have two independent variable. For example, if you have, okay, if let's say a function z is given of x and y, but where our x is a function of r as t, function of r and t, and y is a function of r and t, and r t, this is r and t. Okay, so for this, if you want to find dz dt, right, so you can differentiate the z. We can find dz respect to r and with respect to t. So for z dt, we have del z del x del t plus del z del y del t. Okay, so also you can find del z del r, this is del z del x as x del r plus del z del y del r. Okay, of course you can always extend this. If you have, for example, r the free variable rts, then you can find del z del s. Also, if z depend, for example, x, y, w, we have three variables here, and then each of those x, y, and w depend on, let's say, r, t, and s. Okay, so you can differentiate, you can find z, dz d r, dz dt, dz d s, but remember you need to consider each of the variable in z itself, x, y, and w. So just extend those things. Okay, so let me give you the example for this. If z is equal to ex sine y, okay, where x is st squared and y is st squared t. Okay, s squared t. So we want to find del z del t and del z del s. Alright, so for del z del t, okay, so we have del z del x del t plus del z del y del t. So this will give you del z del x is ex sine y, del x del t that you have 2st, okay, and what else? Del z del y, you have e to the x cos y del y del t s squared. Okay, then yeah, you can simplify this and then substitute each x with the given function x and y. So you have here, so ex, your x is st squared sine y, your y is s squared t, then you have already those t, 2st plus that one ex, so est squared cos y, your y is s squared t, and then s squared, everything there s squared. Then of course you can simplify further. Also we can find del z del s. Del s is given as del z del x del s plus del z del y del s. So it seems that there are many formulas here, but you don't have to memorize all these formulas. You need to understand this thing. As for this, I just recap here. Z a function of xy, where x and y is a function of r and t. So in this case, the free variables are r and t. So you can see. So we differentiate those functions with respect to the free variable r and t. So you can find dz dt and dz dr. Okay, differentiate the function with respect to the free variable. This is as our final destination. Okay. All right, so I think that's the video number 18. I stop there. Thank you.